because of the often very small value of H plus concentrations, as we mentioned before, a log scale is used to simplify expressing these values. So, for instance, if we want to find the pH, we're going to use this equation here. pH equals negative log of our H plus concentration. Now, the negative sign that's in front of this log is to make sure that most of our small concentrations of our acid are going to be given in a positive value here. Okay, so that's why we got this negative here. So, for instance, right, if I got a 1 times 10 to the negative 7 concentration for my H plus, well, if I need to find my pH value, I'm just going to do negative log 1 times 10 to the negative 7, and then that gives me a pH of 7. Okay, so here's the key trend that you guys want to pay attention to. The greater the H plus concentration, the lower the pH value will be. And it makes sense, right? Because if you got a high H plus, right, that means that you got, right, a lot of hydrogen ions here. So you got a lot of H plus concentration. That means that you're going to have a more acidic solution, right? So you remember, based on our pH scale, anything less than 7 is going to be acidic. Anything that's equal to 7 is neutral. And anything greater than 7 is going to be more basic, okay? Not basic in a bad way, but more basic. So when we look at our scale, right, these are some examples when we look at our pH scale. Right, for instance, if we start at the very top, now notice hydrochloric acid. This is a very strong acid, which we'll talk about in upcoming videos. How do we know if it's strong or weak acid? But if we look at our pH scale here, we can see that we actually can get a negative value on our pH scale depending on how much, right, how concentrated your acid is. In this case, 10 molar, that's a very strong acid there. All right, we already got a strong acid, but it's very concentrated. So this is how we can get that -1 on our pH scale. 1 molar, right, we're looking at 0 with this strong acid. And then we got some other examples of some different acids. Orange juice, right? You know, anybody drink some orange juice, that's going to be sour in your mouth. Same thing with lemon juice, right? Both these things are very sour in your mouth. Urine, you know, your pee, you know what I'm saying? This is a very acidic as well. And then we get to neutral with our pure water. And then we got some more examples, right? Baking soda solution, that's basic right there. And then if we look at the strong base, sodium hydroxide, we can see the same concept is going to apply depending on your concentration. 1 molar sodium hydroxide, we got 14. 10 molar sodium hydroxide, we got 15. So that's how we can see it be above that scale that we're so used to, 0 between 14. So mainly we only use pH, but pOH is very helpful if we're trying to, right, do base equilibrium. Okay, so we'll run into that a little bit later on. But basically, if you want to find your pOH, it's going to be very similar to your pH. pOH equals negative log of your OH concentration, right? So please get that in your brains, right? pH, pOH equals the negative log of the concentration. If you got that, yo, you are going to be very good going forward. Another thing to pay attention to is pKw, right? So pKw is basically this is a very critical thing to know as far as with this equation. So pKw equals the negative log kW. In this case, it's going to equal 14. All right. So basically, we need to understand that our pKw is equal to 14 in this case. Now, because we have this water solution, this is going to help us out tremendously anytime we have water with our acid and base. It's going to help us out determine our pOH or pH. So pOH plus pH equals pKw or 14, right? So if we know that pKw is 14, we can always solve for our pOH or pH in this manner, right? pOH equals 14 minus pH, pH equals 14 minus pOH, right? This is another way to solve for your pH or pOH.